So my name is Richard Mills. I'm with a company called Coveros. I'll introduce myself in a minute. And welcome to my talk, Zero to Federated at the Speed of Jenkins. And this is really a case study of some of the successes we've had in DevOps with at least one of our clients, right? So who am I? Who is this guy up here? So I'm a software developer by trade. So, you know, mad software developer turned mad software engineer. Over my career, I've really focused on a lot, kind of evolved from just being like a C++ and Java hacker into more of an engineering-oriented guy looking at how we build big software systems and how we get them out and make them actually work, right? And as it turns out, over time, I did a lot more automation, right? So when it came to engineering, I looked at tools, and then I started looking at automation. And in doing so, I've now become what's considered the DevOps solution lead at my company, right? So I've got a very close focus on tools and automation. You know, first I was doing stuff that was automating build of software, and then we decided we were going to call that CI. And then it was not just automating the build, but also deploying it somewhere, right? I had to install it in order to test it. And then we decided we'd call that continuous delivery. And now there's this whole touchy-feely thing out there in the world called DevOps. And I don't care what they call it nice, but thank you for inventing a word for what I do, right? This is what I like to do, and it's what I've been doing for a lot of years, right? The way I actually pay my bills right now is I work for a company called Coveros, who, quite frankly, I've more or less worked for my entire career. And what we do at Coveros is we work with software organizations, probably a lot like what you guys work with, helping them build, you know, more secure, better, more reliable systems, better, faster, stronger than they were before, right? So a lot of this and a lot of what I'm going to talk about comes from work that I've done with customers looking at doing agile transformations, right? How do we become more agile? How do we build and deliver software more quickly and just generally better, right? So we tend to integrate with teams and work with them to get this done. Well, what my place has been through a lot of that has been, I always ended up being the build guy, right? So anytime you go in and you do agile, you start thinking, well, if I'm going to do stuff quickly, I need a build server, and I need the build server to do all this stuff, right? So it's turned into really, for our company, Coveros, DevOps and automation has become a first-class citizen in the business that we do. So we now have customers who come to us to ask us to do this. And I'm going to tell you about one of those today, right? And we also, along with that, by the way, provide a lot of training for how to do Agile and DevOps. So that's kind of where I come from. One of the things that keeps me busy and keeps me intrigued and keeps me kind of plugged in is we've kind of assembled over time this thing we call Secure CI, which is just an integrated stack of Jenkins and Subversion and Git and a few other tools that when I go in somewhere and I have to start with something and they have nothing, I'm like, okay, wait a minute. Boom, I push a button, I launch an AWS machine, or I launch a VM that gives me the tools I need. And that's Secure CI, and it's actually, I'll give you a little demo of what we've done with it and how we use it as a tool. So why am I here? Really what I want to do is share with you guys a little bit about some of the successes we had introducing continuous delivery into an organization, a client of ours, which was a major media and advertising commercial company. So they're out there in the world. Right? And what we started with when we went in with them is they were a build organization. You know, they had a bunch of developers building a bunch of systems, and they were definitely using Jenkins for continuous build, and I choose that word carefully. They were absolutely doing continuous compilation. I don't remember if it was actually continuous or whether it was scheduled, but they were definitely doing compilation and building assets that could be installed somewhere. They had a little bit of stuff that looked like unit testing, so they had some JUnit, but everything beyond that was almost completely manual. So all the testing in the test environments that they would do is basically somebody would have to go fetch a build, go drag it over to a machine somewhere, whether it be a VM or whatever it was, and if it was QA would install it on their own machines and they would configure it in whatever magic way they did it. And then if it was the technical operations, the sysops guys, well, they would do it in their way, and they had a completely separate way of doing it, right? So it was very much isolated silos of development, QA, and technical operations, right? Those are the three primary groups. And they had some complaints like, well, you know, we got the system done, and it was code complete, tested, ready to go. We clicked the go button 6 weeks ago. And it took us 6 weeks to roll it out into the various servers out there because we were really afraid of touching anything. We're like, well, we got to do this really carefully, and we got to shut everything down and do it over the weekend. And oh, by the way, it's literally a 24/7 system. We're terrified to touch it, right? So there was a lot of this kind of fear. They had huge pain associated with configuring this giant fleet of servers of like, oh, the new software needs all these new config settings. How are we going to get this done? And I see a few people out there smiling and nodding, going, yeah, that sounds kind of familiar, right? So a lot of us have lived through that. some of this pain was due to the fact that they would create these like 3 or 4 month long feature and integration branches, or not integration, but feature branches for their releases that went in different directions, and it was extremely painful to bring them back together. So they lived with all these pain points on a regular basis. So they basically came to us and said, we want CI/CD. We don't really know what that means, but we know we want it, right? So they come to our door, and that's what we do. They had really spent, over a period of about 2 years, a whole bunch of failed attempts at trying to get continuous delivery in place. And almost always it was the kind of thing where it's a developer at nighttime as a hobby going, well, I have code I see more people nodding, right? I have more code I need to build and features, but oh, by the way, I'm the build guy too, and I'm supposed to make this better and faster, and I don't have time. It's a hobby. I don't have time to do this, right? So they finally came out and they brought in some expertise, and they found us, and that's what we went and did. One of the great advantages we had on this project is it was a greenfield project. It was basically them re-engineering what they called their data management platform. So it was beginning again in a domain that they understood with a completely new design and a lot of new code. So we had a lot of freedom on what we were going to do, right? Which helps in this particular case. And it was a development team of maybe around 50 people. It was probably a bunch more by the time we were done with it. And over a period of initially 3 months and then 3 more additional months, we really went from almost nothing, like absolutely virtually no code, absolutely zero, to a very big build-up kind of federated system. So as far as what we were working with and the domain of where we were, it ended up being what I would consider to be a large federated system. There were about 18 independently built and deployed systems that went on various places. I'll show you kind of a map here in a few minutes. It had a front-end UI, and it had a whole bunch of REST services kind of in components that talked to each other behind the scenes. And it was largely Java-based. It was using Hadoop in the back end, but Hadoop in the end ended up being largely irrelevant. Their typical process was to push this software through at least 3 environments. So they would go into a dev environment, they would go into QA and production, and then depending on what was going on, sometimes it would get pushed sideways into a performance environment, and they had to do a lot of load and performance testing. They also wanted a demo/UAT type environment that could get versions of software when desired, so they could demo to their customers and all that kind of stuff. And where we got, so by the end of really 3 months, but then more systems over the next 3 months after that, was we went to a full continuous build, test, and delivery for most of the systems within that ecosystem, right? And when I say delivery, I am including automated unit tests, deployment tests, smoke tests, integration tests, functional tests, and some slices of performance testing, right? All that was happening through a pipeline that I'll show you guys. All of the configuration for the servers was automated in such a way that you could take, effectively, they would give us a naked VM that had CentOS installed on it, basic Java or basic Unix operating system, and we would lay down everything on top of it and assign what it needed to. And then we build a pipeline so that it would all go automated through this whole way and really just have a push button say, go to prod, right? It was really a checkbox to, yes, approve this and let it go, and it would deploy itself into the production boxes with the exact same automation. Some of the immediate benefits that we saw from this with the teams out there was that new changes to software were in the dev environment in minutes. It was anywhere between 3 and 15 minutes, depending on how big the unit tests were. It would be within a test QA type environment within an hour after it passed a certain set of internal functional tests in the dev environment. And then it could go to prod conditionally an hour later based on approval sort of thing. In reality, it went to prod once every few weeks sort of thing. That was and that was an amazing cultural change for these people, right? The developers now were able to develop and test this software across all of these components. I'll show you a diagram on the next page here, but there are many, many components, and one of the big integrations problems is, I'm building this component on this team, how do I know it works with that component? I need a place to play with that, right? And it allowed us to basically get that in place very quickly and detect problems. So these developers were able to rapidly find the problems that they were introducing effectively in the system because of the fact there were a lot of moving pieces, right? It was a classic integration problem, right? So what it came down to is they had a 1 to 2 week cycle that they could go from we got a new requirement of something we want to do, to an actual delivery to production if they were ready for it. Now, given that, there were a bunch of challenges that we had to attack as we went through that. So now I'll kind of switch over and tell a little bit how we did this. High-level design of the system kind of thing, doesn't really matter what it was doing, but the interesting challenges that come with a system like this is that you have many components. So let's see, does it now show up? Yeah. So, you know, pick a taxonomy component, right? This is a component, a software component that, let's say, is a web service. It's being deployed onto, as it turns out, multiple services. It's load balanced behind something, right? So any communication with it is going to go round robin across a bunch of services, and it's a typical configuration, right? That thing talks to a database cluster on the back of it, which is a shared clustered, as it turns out, graph database called Neo4j. And anytime you see one of these lines, when you're building independent components that have to go to different places, the other components that talk to it have to know where it is, right? I need to know the endpoint URL to talk to that service, right? And it may be changing over time. So configuring that alone can be challenging, right? That's a challenging kind of deployment problem that we often deal with. And that's where systems like Chef and Puppet, and, you know, Kosuke mentioned a few others this morning, and Docker, a lot of these help us do that. So that's one of the challenges. The other challenge that I kind of mentioned was organizational. You got different teams working on the segment processor or the taxonomy or the analytics UI. In our case, some of those teams, like half of them were in Europe and half of them were on the East Coast. There were some out in California, right? So you have kind of this geographical problem that what you don't want is somebody checking in a piece of code at 5 p.m. on the East Coast, and then the European guys wake up the next morning and have a bunch of broken code, right? So we're trying to look for continuous feedback, and that's really where CI and CD come into play, right? You have all these different challenges for each one of these, right? I need to be able to build the software. I need to be able to deploy that software and configure it. I might need test data. That was an interesting challenge with the Neo4j database, is that every time we ran tests against it, it made a disaster of the database, right? Because a lot of the tests were like, how do you insert a node, delete a node, clean up a node? You know, the solution was either have the tests be able to roll themselves all back out, or just reset the database, which we ended up writing some jobs that would just reset the database back to a known state when they ran tests. And then, of course, testing the software itself, right? All of these are things that need to be integrated together. So how do we do that? What did our solution look like? So our solution in the end was a pipeline that involved Git, Jenkins, Sonar, Chef, a bunch of other stuff, right? So all of their source code was stored in Stash, which is the Atlassian implementation of Git, right? So it's a Git server. And all their source code is, of course, stored in there, right? That's also, by the way, the same place that we store all of our continuous delivery scripts, right? So Kosuke was talking about this morning, you know, everything is code, right? And that's one of the principles of DevOps, is commit everything. Anything that you do, everything that runs in that Jenkins server, store it somewhere, right? So if you need to replicate it, if you need to go back, it's the same principles of software engineering that we talk about, right? So all of that stuff would effectively feed the Jenkins server, right? So Jenkins was kind of our center brain for everything. And we use SonarQube and jUnit and a number of other things to kind of build and package that software. All of the assets we were delivering, by the way, get packaged up into Linux RPM, so that was stored, and that would get stored in a Yum server so that it was available. Then the next stage we really do is we use Chef very heavily on this project. And Chef is a configuration management framework, as Kosuke described it. It's one of the convergence-based frameworks that allows you to say, I want something that looks like this, make it go look like this, right? And we would use Chef to go through what I call the provisioning stage. I'll talk about it in a little bit. But that's really the initial configuration of the software to make sure that it's ready to, it's got the middleware, it's got all the basics that your software needs on top of it. Because then our next step really was to deploy our custom-built software into each of those environments, right? And this went into, as it turns out, it was an internal cloud system they used. They were using vSphere and a few other you know, heavy-duty internal cloud rack data center management stuff. But they had an internal cloud that they would use. And then we would go out and we would sick testing on it. And we used a combination of robot framework, TestNG, and Selenium to basically achieve all this. And wound it all together so that we had a pipeline that could deliver all this, right? You hear the term pipeline a lot in the continuous delivery world, right? So what did this pipeline look like? Well, at the highest level, you're looking at any time somebody commits a change, the first thing that always has to happen is build. right? And build to me includes compiling the software, packaging the software. It includes running unit tests, meaning anything that you can do during compilation of the software where it runs internally and doesn't have to be deployed somewhere, right? It includes running things like static analysis. I mentioned on the previous page, using things like jUnit and Sonar. How many people know what Sonar is? A few, right? Sonar is basically a software analysis metrics package and database of software metrics that allows you to get a good view of the quality of your software. It keeps things like coverage, it keeps complexity metrics, all kinds of static metrics, but it's a quality assessment for your software, right? And that all gets wrapped up into the build phase. So by the time you're done with this, it's built and unit tested. It's effectively simulating what a developer could do without having to deploy the software. Our next step was what we called our delivery pipeline. And that, as it turns out, ends up being a whole bunch of steps that I'll talk about in a minute. But this is the delivery pipeline that says, well, I need to put it into a dev environment and install it there and configure it there and test it there, right? And then I got to move it on. I may need to go to a QA department, right? So I got to go to a QA environment and launch it and test it and do that stuff. So these were 3 statically kind of provisioned environments. And then eventually I might go to prod. So the pattern that emerged for us is we kind of chunked all this delivery pipeline stuff together and called it one thing, right? It's like do a bunch of magic, and then eventually what I want to get to is what we called a to-prod phase, right? Which looked a lot like the other phases, but really had a gate before it was allowed to go there. For each one of these phases that looked a lot the same, whether it be dev, QA, or quite frankly, even prod, the first step was what we called a publish step. And this is, on the previous stage, I said we build RPMs, and then it needs to go to a YUM server. And if you guys are familiar with Linux, YUM is really just a package installation. I mean, just like Windows Update, right? It goes out to Microsoft and pulls down packages and installs stuff. Well, it's the same idea in Linux, right? YUM is one of the packages that's out there. So anyway, CAD's publish really was just our YUM publishing. So it would effectively take the assets that are installable and put it into what we call the dev life cycle, meaning this is now the latest version of the analytics API that can be installed in dev, right? And that was the publish phase, right? Then we would deploy it, and deploy it meant take what's there and install it on servers. And remember, this is being instantiated effectively for 18 different components. So we had 18 versions of these pipelines that used a lot of shared utility jobs, but effectively that knew what to do for each one of those components and could happen at any time, right? So the deployment phase took care of that. Then the next phase we always had was something we called deployment testing, right? And this is basically the smoke test for deployment to prove that I got the software installed correctly. You know, I got the right version of the software installed on the box. The Tomcat service came up and responds with a OK, basically at 200, right? In fact, I can get a page. I don't really care what's on it. I just want to know that a page comes back, right? And that some very basic connectivity is provided so that when I'm looking at this big crazy diagram, I want to be able to prove that I configured it right. So let's say the taxonomy component can talk to the analytics UI and the data store, right? That's what I'm trying to prove with a deployment test, if you will. And that was always a part of our deployment. And that at least proved to me basically that I did my job right. It didn't tell me the developers did anything right or the software works. It just means that I got the software installed and it's functional, right? And then finally, we would do, test deployment. And then depending on the environment, we had what I will call the functional test, right? So now I have a deployed piece of software that I've declared works. Now, this is where you start doing that functional testing. It could be regression suites, it could be integration testing, it could be all kinds of stuff depending on the component. But this is where we use Selenium, we use Robot, we use a variety of frameworks to start pummeling that application and making sure it's producing the right answers, right? If it's an API, I need to query it and make sure the right stuff comes back. If it's a UI, I need to hit it and make sure it does the right thing, right? And that's the phase. Assuming something like that works, I move on to the next step, and I promote to QA, and I basically go through an almost identical pipeline. And in many cases, using the exact same deployment job that's been parameterized slightly different, right? Finally, when I get to the prod step, there's kind of a gate in there that has a button that says, do you want to go or not? And if you hit go, it repeats the process, publishes it up to CADS, which is that repository again, deploys it, tests the deployment, and then does not do any additional testing, right? I've already proven before I go to prod that the software works. I'm not going to test it again, right? There are certain situations where I want to test to make sure things like data compatibility, did the upgrade happen properly? So there may be some stuff, but for the most part, we're not doing a lot of testing in production because I don't want to mess up my production data, right? So that was the issue. And that's kind of the concept of how we designed our pipeline. Now, in actual Jenkins, what did that look like? Well, here's a nice eye chart for you. But the concept is, remember those 3 phases I had, build, deliver, to prod, right? Well, that's exactly what appeared in our pipeline design, right? So we had kind of 3 master jobs that we chained together. This one, you know, you can't read it, but it basically says build. And in the middle, it basically says pipeline. And in the end, it basically says to prod, right? And we can see that I keep going through these green phases where the build is happening and it's green. Green is good, right? Green happens, green is good. We notice down here, one of them was red and it failed. That obviously, when it got into the pipeline to go through dev and QA, at some point it failed, right? This blue really just means, hey, I'm ready. I never ran. But if I, as it turns out, there's a little clock button on here, and anytime we would go to prod, we would pick whichever version it was. If I wanted 2.4 snapshot, whatever this one is here, to go to prod, I would find its little blue button, click it, and it would take that version of software and deliver it into prod. And that's actually one of the nice things about what this, it's called a build pipeline view, and it integrates one of the plugins in Jenkins that we used that gave us this nice visibility so that at any time I can see what's happening. I know where things stand along the chain, right? Now this actual, the pipeline itself was a complex job that we implemented in what's called build flow. It's very similar to what Jesse just talked about with the workflow plugin that they've now built within CloudBees and what Kosuke was talking about this morning at the kickoff. Is it's effectively, you know, again, I don't care if you can read it, but it looks like program code. And it says, I want to run this job, then run this job, then run this job. And then if this happens, I want to do that. And I can do loops, and I can do conditionals, and I can do all kinds of neat stuff. I can do retry. You know, every once in a while, we would have publishing steps that would fail because the server was flaky and the network would go out, right? So I can put retry loops. So it allows me to kind of inject real logic into what's going on, right? And if we look at it from an output standpoint, you know, it says this failed, or this started, you know, job started, next thing happened, passed, good, next thing, next thing, next thing. And I can do things in parallel. And it allows me to kind of describe fairly complex jobs of general orchestration, right? This is the waving and saying, you go do this, and you go do that, and you go do that, right? And that kind of stuff happens, and we use the build flow plugin for that. And it was very effective for us. So one note on orchestration, right? How many people here, well, how many people are using Jenkins right now, right? Almost everybody. Anybody coming here because I don't know anything about it and want to learn Jenkins? At least a couple, right? Now, how many people are doing what they would consider to be some kind of continuous delivery where you're doing deployment, installation, and testing? Fewer, okay. Anybody here using Chef? Dozen-ish. And how about something similar to Chef, like Puppet or Ansible or one of those? A few more. Okay. So one of the biggest problems often with building up, and let me pop back to the diagram, building up something like this is even Chef, Puppet, Ansible, whatever they are very good at packaging a set of instructions that say, for this kind of server, it's a Tomcat server, do these things to install it. A lot of times what it doesn't give you is, oh, you have 3 Tomcat servers, and they all need to talk to each other and register themselves with a load balancer. Well, what does that mean? You know, it's this concept of what we call orchestration, and it's one of the harder parts of kind of continuous delivery is trying to configure a fleet of servers to do the right thing. So in our case, we used Jenkins and Chef to be able to do this, and we used Jenkins really as that center orchestration point, which means all activities originated from Jenkins. Jenkins knew when it had a new software system to deploy, and it said, I know that this analytics API is supposed to go on an analytics server. Now, the question then becomes, well, where or what are the analytics servers? How do I find them, right? And the way we did it is we went through what we called a provisioning step, and we used Chef. Chef is a configuration management framework database system that allows you to provide instructions for configuring something, and then, oh, by the way, the central Chef server itself keeps track of what's been done and who's where and who's got what. So the way we ended up orchestrating this is Jenkins would invoke Chef, and there's a command line tool called knife. Doesn't really matter if you don't know what that is, but it's basically just how to control the Chef enterprise, if you will, right? And we use the Chef configuration database for a, quote, environment, meaning dev or QA or prod, to store the data about what the machines were, right? So Chef knew that for an analytics API, we had 3 servers, server 1, server 2, and server 3, right? So Jenkins didn't need to know that. All it needed to do is query Chef and say, give me the 3 servers that I need in order to do stuff. Now, as it turns out, the way that we told Chef what was the first time is during its, quote, provisioning phase, meaning when these machines are born, we would enter a data file somewhere and then we'd hit a Jenkins job, which would read the data file and shove it into the Chef server and tell it what it is. And at that point, Chef knew what those servers were forever, right? So when we needed to do something, we would use knife to fire that information off. And then effectively, we would query it and say, okay, I just want you to use secure shell, remote login, to go to those 3 servers and tell them, do your Chef instructions, right? And those servers, and one of the things Chef does for us is those servers basically phone home to the Chef server and go, Jenkins told me to do something. What am I supposed to do? Right? And then Chef would distribute the instructions and it would do its stuff, right? So the key point to take away from here is we used kind of that CM database within Chef to maintain everything. So it was a central point of knowledge, and Chef just would kind of either push information in or query it out. We even set it up, the kind of final bullet emphasizes that whenever Jenkins deployed version 1.2.4 to prod, we had it set up so that it would actually go tickle the Chef database and say, hey, store this information for me. Right? So it would store, well, 1.2.4 was installed on this server on this date. So Chef always knew that. And we use that as kind of our central knowledge point, and then Jenkins as really the trigger point to control all of that activity. One of the things that we discovered as we were going through this whole episode, if you will, is we ended up with what I'll call a medium-sized installation of Jenkins. We had Jenkins with 3 or 4 slaves, and by the time I was done with it, there were easily a couple hundred jobs controlling everything that was going on. Now, it's not 4,000 jobs, which is a lot of jobs, but it's not a dozen either, right? And what we've learned over time is anytime you start getting above a few dozen jobs, you need to start figuring out how to organize these things so you can navigate through your system and get done what needs to get done. Because ultimately, there are going to be some things that happen by themselves, and you want to be able to monitor whether those are doing things properly. There are other things that you're going to manually want to go find and do, like you're going to want to kick things off manually. For example, that 2-prod thing, right? So one of the tricks we use a lot within our Jenkins, anytime I set up a Jenkins server, is we use what I'll call HTML navigation. Meaning, I realize you can't read this, doesn't matter, but the point is you can kind of see these bullet points and links, right? And what we do is we construct HTML pages in the description. So here, I'll show you an example. So that when I go to a Jenkins server, I log in, and while this is one of my secure CI demo servers that I was talking about, by the way, there's not really all that many jobs. But what I do is I can use and this is basically on every single page in Jenkins, there's this description page, this description thing, right? And you can add, how many people use descriptions on their Jenkins jobs? Yeah, a few, good, right? Well, one of the things that we use very heavily is, let me go back. We use these descriptions to basically self-document how to use the system, right? So I construct navigation that says, oh, by the way, start here. This is what this demo is about. Go kick this. And if I want to do a build, I can kick it and it'll go off and do stuff. I was like, this is what it actually does. There's many phases, right? If you want to go to the other things that are related to it, here's the quick links to the places you might want to go. If you want to go see a view of what's going on, you can go to this delivery page. And this, by the way, this is just, come on. Shrink. There we go. This is another view of a pipeline, right? So this is called a delivery pipeline view plugin for Jenkins. It's just a different way to view slightly more complicated jobs, right? The one I showed you guys was very linear. It's 3 steps. It's really easy to view. If you do that one where you've got 12 steps that have parallel tasks and everything, you end up with a 4-foot wide page of stuff that's very hard to digest. The delivery plugin is just a different mechanism you can use that kind of groups things together, but eventually you end up with spaghetti again. Right, but with it, I can see stuff like, oh, the demo application built, and then it triggered a few other things. In this particular demo, the way we've set it up is we use Ansible, Puppet, and/or Chef to launch machines into AWS and deploy software onto it. Why 3? Because we use it as a demonstration that we know what we're doing and we can do 3 different ones. But in reality, most recently I ran the Puppet one where we launched a Puppet. We used Puppet to launch a machine. We configured it, installed software, then we ran a bunch of Selenium tests, then we ran a bunch of security tests, then we ran some other stuff. We ran some security tests, which apparently failed. So there's something interesting, right? Quick view, I can tell exactly what's broken, right? So we use HTML navigation in these plugins really to be able to navigate through a larger system. And as soon as you start talking about continuous delivery in an enterprise, one of the things you're trying to do is bring together people to understand the system, right? And if people can't use it, they're not going to use it. Kasuke mentioned this morning that we're starting to share paradigms, right? We've lived in a world where dev and ops were completely separate. Dev's going to use like Maven deploy or something to deploy their software and test it and do crazy stuff. Ops, if you try to give a Maven script to an ops guy, he's going to punch you in the face, right? He does not want your Maven script to try to deploy software. He wants something that they can maintain and live with. So starting to use, providing a usable system makes a huge benefit, right? Error communicating, that's awesome. So anyway, so HTML navigation often becomes very powerful. The other thing did I talk? I didn't get that far yet. Okay. So the other thing, so other success points within our implementation, right? So how did we deal with kind of trying to deal with both development everyday continuous software versus what I'll call release candidates, right? So a lot of times when you're building software continuously, you're doing many, many builds, right? The developers might commit 10, 15 times a day for a particular team. You're developing many applications. In a Maven world, you tend to call those snapshot builds, right? They're not really release candidates. They're not proven yet, but you need to get them out there quickly and rapidly change them, right? Eventually, we wanted release builds, which is, okay, I've been doing this development, and if you can kind of read it in the corner, these tend to indicate snapshots, right? 029 snapshot, build 1075, whatever. The point is, these are continuous ones that are happening very frequently. We also wanted to be able to do, okay, we think that one's done, we're going for an official packaged build. We use something called the Maven release plugin. Anybody here using Maven? Familiar with it? A dozen or so. Anybody using the Maven release plugin? At least a couple others, right? And it's got a couple steps. Well, there's a nice plugin for Jenkins, actually, called the M2 release plugin that allows kind of a clicky user interface. So when I do a build, you can click a release build, and it will automatically update all the palms and incorporate all the release information to it to be able to publish that downstream. We ended up using it, by the way, with something called a JGitFlow Maven plugin, which was a mechanism that allows, if you're using Git and GitFlow, how many people are using Git? Again, about half. How many people are using GitFlow? Much smaller. GitFlow is just, it's often labeled as a successful branching pattern for version control systems. Happens to be for Git, but it's a way of managing release branches and development feature branches and hotfix branches. And honestly, if you're searching for a good branching pattern, no matter what you're using, Git or Subversion, go look up GitFlow. It's honestly, when people ask me, what should my branching strategy be? I'm like, you start using GitFlow, and when it doesn't work for you, come back to me, because a lot of times it's an easy solution. But anyway, there's a JGitFlow Maven plugin that I think is put out by Atlassian that ended up working very well with the M2 release plugin and solved some of the merge integration problems that can get caused by using the Maven plugin. Anyway, so that's a typical build. It was all done with Maven. The one thing I will say about anybody using Jenkins is use the build name setter. How many people in this room who use Jenkins have ever had to click through, 50 different builds, looking at the parameters, trying to find the build that they wanted that happened? a couple people, right? And if you've ever done this, it drives you insane. You're like, oh, well, there's build 38, and build 37, build 36, and build 35, and one of those built the thing that I care about. How do I find that? Well, I'm addicted to what's called the build name setter, and it's a plugin within Jenkins that, let me even see if I have it on this one. If I pick some random job, come on. It's thinking. I don't even know if I have it installed on my demo server, but it allows you to basically, and while that's trying to come up, it allows you, instead of, number 8 or number 7, it allows you to put textual names associated with the build. So I know that in this case, it was 029 snapshot develop, right? And I can look back through them and see what exactly failed. In the case of the release plugin, it gives me this little locked kind of icon-y thing that says, oh, by the way, that was an official release that happened. So do I have the build name setter? Let's see. It's usually in, nah, I don't even have it in this one. Okay, never mind. Yes, leave page. So build name, that was another plugin that we found that was very useful for kind of digesting interface, information rather. And again, these things are really just aimed at trying to provide an interface so that everybody can use the system. Because it's one thing if you have a Jenkins system that one build guy understands and knows how to go use. It's a totally different thing building a system that conveys useful information and allows you to get to where you want to go. I did mention, we had hundreds of jobs. So one of the strategies for us was to use what we called a dashboard. There's a dashboard view plugin, and there's something called the nested view plugin. The dashboard view, to show you kind of a live copy of it, gives you this really tight, like if you were to use just, do I even have, whatever. It gives you this nice tight kind of compact representation where, on this page, I had probably 50 jobs that were being displayed on this page that I could see green, red instantly. In reality, here's a couple red builds. Those are always the interesting ones, right? The other things, it's configurable. You can say, well, this is the order of what's been run recently. So that's the recent stuff. Here's the unstable stuff. This is what needs attention, right? You got broken builds, go deal with them, right? So it allows us to quickly digest it. The other one I talk about is the nested view. Nested view, basically, Jenkins comes with the ability to kind of do these tabs across the top, right? That just comes right out of the box. What it doesn't necessarily do is give you an easy way to deal, like normally what you end up with is one tab, and chug it as it comes up, with this big long list of jobs, right? And it's not very granular. Well, the nested view allows me to do stuff like go, oh, well, there's pipeline jobs, right? Which is a folder that has another folder within it. So I can create a hierarchy of navigation to kind of go through things. So if I go to the Puppet pipeline, I can go here, and then it has more tabs across it. So it's one of the plugins, again, that I like to use to make my UI digestible so that I don't end up with a Jenkins server that has, 40 tabs across the top here. And if I go to the all job, the all job should never be your default, right? So that even this little demo server, right? This server doesn't even do anything, and I've got 40 jobs, right? So anytime you get a complex thing, you need some way to be able to digest it, right? So I will say, in going through this project, we set up all these jobs and we did all this stuff and deployed it. And probably one of the proudest moments I've had, certainly on that project, was the scene was basically, they locked us all in a room for a week, right? There were about 20 of us, and it was a bunch of developers, a bunch of QA, a bunch of tech ops guys, and said, we don't have a UI for this thing. Build one, go. Don't come out until you're done, right? So these guys, we all spent a week in a room, and we just hacked this thing up, and they built this UI. And actually, I use the word hacked, but they constructed a completely working UI that worked in this federated environment from scratch in less than a week. They took a prototype of something they wanted it to look like and built it, right? So at the end of the week, they go through, and the product manager gives a demo to the CTO who's paying for this whole multi-million-dollar project. And the demo comes off really well. The UI is awesome. It looks really cool. And the CTO kind of laughs about it. He's like, well, that was really an awesome demo. It's all being done with CI/CD, right? And kind of laughs about it, like assuming that there was no way in hell that's the way it was being done. And I was there, and I was like, well, yeah, of course. His response was, really? And I'm like, yeah, we built all the automation code with the developers while they were writing their code. And at that point, you know, I don't know, the light bulb really went off in his head, and it was like, wow, that really is amazing. And what the team had concluded really is there's no way. Yeah, question?
5 minutes.
Oh, 5 minutes, good, thank you. Hey, no, it says I have 5 minutes and 1 second. Anyway, so it really, and the team really agreed at that point that the ability to rapidly push this code through and build one more component of automation and link this into Jenkins was a big part of their success. So, you know, what it comes down to is when I look back through it, I'm like, a lot of people come to us and they're like, well, we want to do CD. We're not really sure what it means, but we want to do stuff. Where do I start, right? And what I tell them is, this is whether it's CI, CD, or anything in between, figure out what happens most frequently and automate that first, right? That's your bottleneck, right? So what's the thing we do most often, right? We compile stuff, right? Well, make sure you're compiling software, and that's where everybody starts with CI, right? But then after that, you're like, okay, now you got to make sure that's good. So for everything that you do quickly, you need to find a way to test it to make sure that whatever you just did quickly is any good. Because I will say it's really easy to deliver garbage quickly, right? You can check in whatever crap you want. I can put that in production tomorrow if you want, or in 20 minutes. But it may be garbage, so you might have to deal with that, right? So for everything you do, you need some way of testing it, right? So after you get it compiled, the next most important thing is how do you deploy your app, right? You're going to change your app a lot, so figure out how to deploy that. Some people will start with like, well, you know, if you're going to do CD, you need to build up from bare metal and put your OS on top of it and do your other middleware stuff and then deploy your app. I was like, well, yeah, but how often do you do that? The answer is not very, right? Unless you go to the end, which is if you're launching a lot of Amazon dynamic servers, that's a different story. But for the most part, you need to be able to configure and deploy your application, right? So figure out how to do that. And then, oh, by the way, what do we do next? Well, you better test that, right? You need a way to prove that whatever you just deployed is in fact good, because without that, you can't really automate any further. Once you can do that well, now you can start thinking about, okay, well, that middleware that I depend on underneath it, Tomcat, Java, Neo4j, Oracle, whatever it is, right? You need a good way to be able to build that up too, because when you get new servers, you don't want to take 3 weeks to launch a server, right? You want to get it quickly and build it up to a state that you understand, right? So you don't want a bunch of written steps, and if you do, by the way, just write it as a script, right? So we do that. So do all that stuff. Configure new servers, that stuff. Again, don't forget automated testing. It's what proves that what you have is any good, right? What you will find is, I absolutely recommend use the build server for the center point of everything, at least initially, right? You may find that there are other products, you know, we looked at Rundeck or a few others, Chef Enterprise, Puppet Enterprise, that allow a different kind of operational control point for doing like server upgrades and whatnot. That might be fine, but certainly in the simple case, use Jenkins as the center point. I'm assuming you're going to use Jenkins if you're at a Jenkins conference. There's other build servers you could use as well, right? The other thing is eventually you're going to have to figure out how to engineer your pipeline. When you start out, you're going to have a spaghetti, you're going to have a little bit of stuff, and then you're going to have a lot of stuff, and none of it's going to be designed the way you want. You're going to have to figure out how to re-engineer that and support that. Once it becomes live and kind of in production, people will depend on it. When you're trying to tweak it and you break it, they're going to be very mad at you, right? So you need to figure out how to kind of deliver stuff into your Jenkins server and into your automation so that you don't break it as you deliver things. We've stood up extra Jenkins servers, right? We do all our development over here, and then when it works, we move the configuration over to the first one. So you'll have to think about that. Thank you, guys.